mercury, it's released through industrial emissions in a gas form, and when it's in that gas form, it's able to be transported over very long distances in the atmosphere. So what that means is that mercury that's released from industry in North America or Europe or China can make it all the way to the Arctic. Changes that are occurring in the climate in the Arctic can influence the way mercury moves through the environment, and it can influence how much mercury ultimately ends up in lakes, ponds, and wetlands. And this is important because it's aquatic environments where mercury tends to be converted to its most toxic form, and where you tend to have the most risk of exposure to mercury for humans and wildlife. So what we wanted to know is how is climate change influencing how much mercury is getting into lakes. And so to do this, we used lake sediment cores. We can take a sediment core, we can slice it up into thin little layers, and those layers can act like pages of a history book. And we can measure the mercury in these sediment intervals to track how mercury has changed over time. All of them are going to show the effects of mercury emissions from the Industrial Revolution beginning in 1850. But the timeline of climate warming is going to be different. We're going to have climate warming acting at 1850, climate warming starting to act at 1950, 1990, and lakes that have no climate effect. In some lakes that responded later to climate warming at around 1950 to 1990, what you see is mercury increases become enhanced when you have climate warming. So the combination of climate warming and long-range mercury transport does seem to enhance how much mercury ends up in the lake in some lakes. So there are factors like shading and then elevation that can influence how early a lake responds to climate warming.